Hi everybody. So we're going to talk a little bit about the compounding formula and compounding, why is it that way? I couldn't think of a better title. So we're going to begin with the idea of simple interest, which is principal times rate times time. But when we're deriving this, we're going to think about time as yearly. So we're going to deal with it as 1 year increments. Okay? So we're going to assume that we are starting with P dollars. Okay? In other words, that's our principal. And remember that T is equal to 1. So in our PRT, that's a 1. In our RT, that's a 1. Okay? And we're traveling at 1 year increments in time, and we need to think about it from that perspective. So we're going to start with P dollars, and we're going to try and figure out the amount of money that we have off in the future. So we're going to take the P dollars and we're going to add on the interest. Well, the way we determine interest from the simple interest formula is P times R times T. Now our T is 1, so really it's just PR. Okay? Now this P and this P are the same dollar amounts. So we're going to factor it out, and we're going to really have 1 plus RT, but T again is 1. So it's really 1 plus R. So at the end of year 1, we are going to have P times 1 plus R dollars. This is our new principal amount. So we're going to start year 2 with P times 1 plus R dollars. Now, this is going to be our new principal. So we're going to work to figure out what we're going to have at the end of year 2. So this is our starting amount, the P times 1 plus R. And then we're going to add to that the amount of interest. Well, it's the principal times the rate. And remember, time is 1 because we're dealing with 1 year increments. So we have P 1 plus R times R. Now you'll notice, again, that principal amount is the same amount in both of these terms. So we're going to factor that out, and we're going to be left with a 1 plus R. Well, that 1 plus R and that 1 plus R are the same 1 plus R, so they'll come together and we'll have it to the second power. So at the end of year 2, we have this to the second power. This is now the value that we have in the bank at the start of year 3. It's the P 1 plus R to the second power. Well, that's our principal amount. So we're going to take our principal amount and we're going to add to that the interest amount. Well, the way you determine interest is you take your principal, you multiply it by your rate, and remember our T is 1 because we're dealing with 1 year increments. Okay, so again, this part of this term and this part of the term are in common. So we're going to factor it out in front, and we're going to be left with a 1 plus R. Okay, so this 1 plus R is the same as this 1 plus R, so we now have P 1 plus R to the third. So at the end of year 3, we have the 1 plus R to the third power. So what ends up happening is, as long as we're dealing with annual compounding, we've got A is equal to P 1 plus R, and I'm going to put a T up here. And this T represents the number of years. Actually, though, this exponent needs to be the number of times that we're compounding it. Right now, it's the number of years because we're dealing with it every year. The formula gets tweaked a little bit. And the way it gets tweaked is if we're doing something like quarterly, so your N would be 4, or semi-annually, your N would be 2. If it was monthly, your N would be 12. And if it was daily, your N would be 365. So this exponent is really the number of times that you're going to compound it over the length of time it stays in there. And so you do that by doing N, your number of compoundings, times T, the number of years that you're going to let this sit in there in your bank account. And this N underneath here is taking your rate and dividing by it. So an example, suppose you have $50. They're going to give you a rate of 5%. You're going quarterly, and you're doing this for a time of 50 years. Well, the way you punch that into your calculator is go 50, left parenthesis, 1 plus 0.05 divided by 4, because quarterly is a 4. And then you're going to raise that to 4 times 50, because you're doing this 4 times for every year, and you're doing this for 50 years. And then you punch that into your calculator and you get your value. Okay, hopefully that's a good example for you and it makes some sense.